this question. Now, if you look at the question clearly, you can see that it is coming from the first law of thermodynamics, because see that the gases in a cylinder of an internal combustion engine has a specific internal energy. So let's write the formula down and let's see. So it will be like, yeah, so let's see. It's going to be like the change in U is equal to Q minus W here. Then we know that the change in U is equal to U2 minus U1. So in all we have U2 minus U1 is equal to Q minus W here. So this becomes the formula that we're going to use to solve this question. So from this question, it says that the gases in the cylinder of an internal combustion engine has a specific internal energy. So you are given a specific internal energy that becomes your what? So let's write the data down. So first of all, we have our U1 to be equal to 950 kilojoules per kg. Then and a specific volume of 0. So we have our V12, which is 0.08 meter cube per kg at the beginning of the expansion. The expansion of the gases may be assumed to take place according to the reversible law. So that means we are using the law of PV exponent 1.4, which is equal to C. Now, the expansion of the gases may be assumed to take place according to the law from 50 bar. So that means at this point we have our P1, which is equal to our 50 here, alright, times 10 raised to the power 5 here. Then lastly, let's see. Then we're having our P2, alright. So P2 to be equal to 1.6 times 10 raised to the power 5, because it is bar. Do you know our V2? Our V2 from the question wasn't given, but it says that the specific internal energy after expansion. So that means our U2 here is equal to 180 kilojoules per kg here. So we need to start the work. So first of all, we know our U2, we know our U1. So U2, U1 was given. And what about our Q? It says that it's calculate the heat rejected to the cylinder, right? Alright. So first of all, we need to find for our work. We know our U, we know W. We know our V1, we know our P1 too as well. So what are we going to do? So first of all, we are going to solve for our work. Then we know that from the thermodynamics, for the second video or the first video that we watched, we know that our W was equal to the P2 V2 minus P1 V1 here, right, on 1 minus N over here. Now we know that our N was given as what? 1.4. Then again, we can see that we have P2 V2, but from the question we have V1, we have P1 here, we have P2, so we don't have V2, so we need to calculate for it. But we know that the law was PV, alright, this is maybe equation 1. PV exponent 1.4, so we have P1 V1 1.4 to be equal to P2 V2 1.4 over here. So now, what do we get? So from this, we can say that we are looking for our V2 here. So our P2 V2 1.4 is equal to P1 V1 1.4, divide both sides by P2, P2, we do the cancellation. So now I have our V2 is equal to the square root of the 1.4 over here is equal to the P1 on what? On P2 here. Alright, times V1 1.4. So this goes across all of them. Alright, so 1.4 over here. Then next, what do we go? Then we can say that our V2 here is equal to the square root of the 1.4 here. So substitute them into it. So what's our P1? So we know that our P1 was 50 times 10 to the power of 5 bar. Then we have our P2, which is equal to our P2 was 1.6, right? So we know that it's equal to 1.6 times 10 to the power of 5 here times what is our V1? Our V1 was 0.08 here, 1.4 here. So we're going to have our V2 to be equal to 0.935 here meter cube per kg here. Now it's time for us to find for our work. So our work is equal to, so from the equation, let's make it this equation 2. You substitute it there. So you can factorize the what? The times 10 to the power of 5 outside. So what's our work? So you put what's P2? P2 is equal to 1.6, right? Multiplied by the volume. So what is our volume? 2. 0.935 here minus. What about the P1? P1 was 50 times the V1, which is 0.0, alright, 0.8 here on 1 minus, so 1 minus 1.4 here. Then don't forget the top one here. Alright, so this one here, which is times 10 to the power of 5 is part of this. So now what's our W here? So our W is equal to 6 to 6 kilojoules per kg here. So now what again? Now since we have our work here, now that means that at this point here, we're going to have our change. So from the equation, so the change in U is equal to U2 minus U1. So let's subtract it. So what is U2? So my U2 is 180 minus what? 950. So now at this, my U changing U is equal to 180 minus 950, which is equal to negative 770. So let's put it there in the equation. So our change in U is equal to Q minus W here. So we now have negative 770 is equal to, what is our Q? That's what you're looking for. Minus W. 626 here. So this will come here. So you're going to have negative 770. Then this will come to the what? Cross the other side. Plus 626, which is equal to Q. Alright, so now I have our Q to be equal to. So negative 770 plus 266 is equal to negative 144 here. So kilojoules per kg, because no mass was